Okay guys, today we're going to do our vodcast with a little assistance. I do have my daughter here today and it might be kind of stop and go for a while and you might hear her in the background. So please just bear with me so that I can get this vodcast up this weekend so you guys can get it done before Tuesday. So today we're going to talk about the fourth and fifth types of reactions on our list, and that is single replacement reactions and double replacement reactions. And if you guys will follow along with me, I think you'll see that these are actually quite easy to recognize, and I'll give you some analogies to use to help keep them straight. So the first thing to keep in mind is that in a single replacement reaction, a single element replaces a second element that is part of an ionic compound. Really, I want you guys to think about a single replacement reaction like if you had a couple and that couple broke up and one of the partners found a new partner. Okay, so I'm going to show you with A plus B and C. So in this case, B and C are a couple and A is a single, and then B and C break up, and so you have B plus A and C. So A came in and replaced B with C. So this is a single replacement reaction. We've taken one of the elements and replaced it with another element. And again, if you think about this in terms of relationships, it might make a little more sense. This is a guy and a girl going out. Another girl comes in and replaces the girlfriend. You have a new couple, and then you have somebody that's left single. So an example here would be sodium and hydrochloric acid. So you have sodium plus hydrochloric acid ends up with H2, meaning the H has gotten knocked out of the couple here, and Na and Cl. Now keep in mind that Na has a positive 1 charge. We know that by looking at the periodic table. And Cl has a negative 1 charge. We know that by looking at the periodic table. And so when we put these guys together, we get NaCl, that we only need one of each of those atoms. And the reason that H2 is because it's a diatomic molecule. Alright, so we end up with hydrogen gas and sodium chloride. And as you can see, you have your sodium has come in and replaced the hydrogen in that couple. Alright, and so if we take a look at balancing the equation, we notice that we have 2 hydrogens over here because it's a diatomic. So we need to balance this with 2 hydrogens over here. And the problem is that gives us 2 chlorines, and we only have 1 chlorine over here. So we need to put a 2 over here with our sodium and chlorine. The problem is this gives us 2 sodiums, and we only have 1 sodium on this side and 2 sodiums on this side. So what we have to do is put another 2 right over here with the sodium, and then we end up with our balanced equation. Now keep in mind that this is kind of a shortcut to our balancing equations. If you don't understand what we just did there and why we added the 2's, then go back and watch our balancing equations vodcasts one more time and go through the count, compare, change, and check process. So I just kind of skipped all of the counting the atoms and the comparing because that's not what this vodcast is about. We're looking at what is actually happening in this equation. Now for a bit of a visual to kind of show you what this would look like on a molecular level, we're going to take a look at a short animation of what we have on the product, on the reactant side, on the left-hand side. We've got sodium, and then we have hydrochloric acid molecules here. So we have a sodium molecule and hydrochloric acid molecules. Okay, and then when on the product side, these sodiums have come in and replaced the chlorines, and we end up with hydrogen gas. So H2 and then 2 NaCl. So the balanced equation shown in animation form, you can rewind that if you need to see it again. But basically what we're seeing is we're just seeing one element come in and replace another. So I'm going to give you a problem of this to practice on so that you can see if you can, 1, set it up, replace, and balance the reaction. So go ahead and try to see if you can get this set up to replace and balance this equation. Pause the video at this point, try this in your notebook, and then come back and see if you got the answer right. Okay, and so we have here on the left, for our reactants, that's our hydrogen gas and our zinc chloride. And what you were asked to do is to predict what would happen if this were a single replacement reaction. So of course you would expect for your zinc and chlorine to break up, but the question of course is, how do you know which one the hydrogen is going to go with? Well, you need to think about your ionic charges. Your zinc is going to have a positive charge because it's on the left side, it's a metal. So your hydrogen has a positive charge because it's in the first column of the periodic table. So it's going to replace, the positive is going to replace the positive, okay? And of course your hydrogen has a positive 1 charge and chlorine has a negative 1 charge. Please remember, one of the things that I'm seeing a lot from you guys is that you don't remember how to determine the charge on those ions. And remember, that's the same as your oxidation number on the periodic table at the top of those columns. So you need to make sure that you do know those oxidation numbers. Okay, so you have your zinc and then you have hydrochloric acid, which is HCl. And of course this isn't a balanced equation because you have 2 hydrogens on the left and 2 chlorines on the left, and you have 1 of each on the right. Well, that's a very easy balancing to fix. You simply put a 2 next to the hydrochloric acid, and this balances your equation. Okay? All right. I want you to pause the video at this point again and try aluminum and magnesium oxide. Okay. If you broke apart the magnesium oxide, because of course the first thing you want to do is break apart your couple, and then you end up with magnesium by itself. And that magnesium, as the metal ion, is going to be replaced by the aluminum, also a metal ion. So you have aluminum, and aluminum has the +3 charge, and oxygen, which has a -2 charge. Okay, aluminum is one of those metals that always has the same charge, so it has aluminum +3, and oxygen is always -2. So you have aluminum 2, oxygen 3. So in order to balance those negative and positive charges, remember to do the bow tie method thing, where aluminum has a charge of 3, oxygen has a charge of 2, and you swap them to make those charges even out. Okay. If you're still struggling with balancing equations, again, if you're struggling with oxidation numbers, you're going to need to go back. All of the videos for those things are online. Just scroll down to the bottom of the page on the class website and find where we did those and review them, because really at this point, if you don't have that down, you're going to need to get extra help to get that done, and it's going to take going back to review those materials. Okay. And so of course, balancing our equations, you count, compare, change, and check, and your end result should be 2 aluminum, 3 magnesium oxide is equal to 3 magnesiums and 1 aluminum oxide. Okay, and that leads us to our second half of this podcast, and that's going to be double replacement reactions. Now, of course, single replacement was replacing one part of a couple in a compound, and a double replacement is going to be if you have 2 couples and they swap. Okay, and I'm going to give an example of this. A very personal example of this was that when we were in college, Bob and I weren't dating. Well, we were dating. We weren't dating each other. We were dating 2 other people. I was dating a guy named Mark, and Bob was dating a girl named Casey. Well, we started double dating, and over time we kind of realized that Mark and Casey had more in common, and Bob and I had more in common, and so we actually ended up with each other's partners. And so this was the perfect example of a double replacement reaction, is that we really just swapped partners and ended up much happier that way. And elements and compounds will do this as well. So if we take a look at this, it's in a double replacement reactions, you have 2 elements in 2 compounds, and they switch places. So the metal replaces the metal. And the letter, just to show you kind of an example, if you have couple AB, say that's me and Bob, and then you have couple CD, and that's Mark and Casey, then you go out on dates and you find out that a much better pairing of these four people, or these four elements, would be to put C and B together and to put A and D together. And this is a double replacement reaction. You notice that each metal ends up with a different non-metal compound or ion. So the example that we're going to give using actual elements, not people or letters, is sodium chloride and potassium bromide. So we have two elements here that are combined, and we have two elements here that are combined. Then after the reaction, a double replacement reaction would put your sodium with your bromine and your potassium with your chlorine. So it's very easy to see that you are simply you are swapping partners with those two elements. So to give a visual demonstration of this, okay, we have a short clip animation. On the reactant side, we have sodium chlorine. That's just your table salt. We have potassium bromide. That's also a salt, but it's another kind of salt you want to put on your food. And so we have potassium bromide and calcium and sodium chloride. And in this reaction, the potassium is combining with the chlorine and the sodium is combining with the bromine. Okay, so I want to give you a few practice questions to do. I would like for you to set these up and attempt to balance them. So I'll give you the reactants and you show me what the products would be, and go ahead and work these in your notebook, and make sure to mark if you have any questions or if you're struggling at any point with what to do on these. So the first, we're going to start off with aluminum chloride and magnesium oxide. So go ahead and pause the video and work that out and try to balance the equation. Okay. All right, of course, we're going to start with our magnesium, and our magnesium and our aluminum are our metals, so we need to find out what that charge is so that we can know how to set up the magnesium chloride. Of course, magnesium has a charge of +2, and our chlorine has a charge of -1, so we need to know how many chlorines we need versus how many magnesiums we need. So in order to balance those, of course, we'll need 2 chlorines and 1 magnesium. So that gives us a magnesium chloride 2, or magnesium chloride. And that means there's 2 chlorines. So for aluminum, we need to do the same thing. Remember, aluminum always has a charge of +3. It's one of the rare transitioning metals, but it actually always has a charge of +3. It's one of our exemptions. And then you have oxygen, and oxygen always has a charge of -2. Of course, if you do the crisscross, you end up with aluminum oxide, which we've seen already before in this podcast. That's aluminum 2, oxygen 3. Right? So let's go ahead and balance it. Of course, that's the count, compare, change, and check. And our balancing is going to put a 2 in front of the aluminum chloride and a 3 in front of the magnesium chloride. Again, I'm kind of skipping all of the count, compare, change, and check steps there. So once we get all of that balanced out, that should look like this. You should have 2, 3, 3, and 1. Go ahead and try this with lithium oxide and iron chloride. And what we're going to do, and that would be iron 2 chloride. So I'm going to let you set this one up and go ahead and try to work it. All right, of course, with lithium oxide and iron chloride, we would end up with our iron, which is +2. The reason that we know this, because it's a transition metal, is that we look at what it's bound to. Here it's bound to 2 chlorines. Chlorines always have a charge of -1, so we know that iron has to have a charge of +2. Okay, and I'm going to rush through some of these because we're running out of time for this podcast, but I do want you to go ahead and try to set these up and see if you can understand and check your answers on why it is set up the way that it is and why we balance it. Okay, so that is the end of today's podcast over single replacement and double replacement reactions. Now you've gone over all of the types of reactions, and of course my toddler needs my attention. So I'm going to give her some of my attention, and I will give you my attention on Tuesday. Thanks. Bye.